area between two curves. Objectives. By this lesson, you should be able to identify the region bounded between two given curves, find the points of intersection given two curves, algebraically and with using a graphing calculator. When appropriate, set up an integral with respect to x that would yield the area between two curves. Understand when finding the area between two curves that sometimes it requires to set up two separate integrals. So let's kind of get into this. So far we've been interested in finding the area between f of x and the x-axis, right? So between like this function and the x-axis. Now we're going to be finding the area bounded between two curves. So if I give you this, if you found the area of A, let's say f of x and g of x, right, the area of f of x will be all of this. If I want the area between f of x and g of x, it's actually just as simple as all we do is subtract off the area of g of x. Because the area of g of x from here to here will get you this. And the area of the red spot, the red area minus the area of the blue one, will get you this, what we want right here. So that's all it is. It's just area of the top function minus area of the bottom function. This area will subtract off this area and you get the middle function. So from an integral from a to b of f of x minus g of x, or integral from a to b of the top function minus the bottom function. That is it. That's how I find the area between two curves. Now, if the graph, keep in mind, if the graph is not provided, we must draw a rough sketch. It doesn't have to be perfect. It's a rough sketch. You want to know what's on top and what's on bottom. If the functions alternate between top and bottom on the given interval, multiple intervals might be needed to find the area. So what does that mean? That just means if you have a graph that kind of looks like this, like kind of goes like this, and maybe another one goes like this. If you look at the one right here, let's say this is f and this is g. Right? On this case, in this one right here, f is on top. But when you go to this one, now f is on the bottom, g is on top. So to do that one, I have to do two separate integrals. One where f is on top, one where g is on top. So that's all that means. So if you have one where it alternates what's on top and bottom, you have to separate the two separate integrals. If an integral is not provided, we will have to algebraic. If an interval is not provided, we will have to algebraically or geographically determine the point of intersection to find the limits of integration. And also, if I don't give you the limits, like here I gave you limits a and b, but if I don't give it to you, you have to find it using algebra. We'll do one of those in a bit. Example, find the area between y equals x squared minus 4x plus 10 and y equals 4x minus x squared on the interval 1 to 3. So they give us the interval 1 to 3. So I know that I'm going to find the area between 1 and 3. So we want to look for this guy right here. So right now, my integral, it's 1 to 3. Now I just got to put the two functions down, so you have to know which was on top, which was on bottom. In this case, the top one is this one, has a y-intercept of 10. That would be this guy. And the bottom one is this one. You can tell it's negative x squared, so it's this guy. So all we're going to do is top minus bottom. So for us, that'll be integral 1 to 3 of x squared minus 4x plus 10 minus 4x minus x squared dx. I would simplify if I use by hand. Let's simplify it. So x squared minus 4x plus 10 minus 4x plus x squared. And that gives us 2x squared minus 8x plus 10 integral from 1 to 3 dx. Then we got to integrate it. Plus 1 divided by new power, plus 1 divided by new power, plus 1. So I get 2x squared cubed minus 4x squared plus 10x. And then with no plus c because we have limits from 1 to 3. And then top minus bottom. So remember, you plug the top one into all of it. So 2/3 3 cubed minus 4 3 squared plus 10 times 3 minus plug 1 into all of it. 2/3 minus 4 plus 10. Now you go through all the algebras to figure out what that is. And I believe it's, if I did it earlier, 16 over 3. Keep in mind, if this was free response, this would be fine. If it's multiple choice, I would have to get the actual answer to match it, and that'll be this right here. Let's do the next one. Find the area between the bounded curves y equals x squared minus 5x minus 7 and y equals x minus 12. So over here I already have a graph for you. So we're looking for this area right here that makes this guy the top. That's right, because here's my area. Let's go above it. That's this guy. And then below it's this guy. This guy's the bottom. So I already know my integral is going to be top x minus 12, because that's the linear equation, minus parentheses bottom x squared minus 5x minus 7. What I do not know are the limits. They didn't give me the limits here. It looks like it's something past 5. It looks like it's something past 0. I actually got to find it. Now, the way you find your limits is you find the intersection, which is you set them equal to each other. So I'm going to set x squared minus 5x minus 7 equals x minus 12. Then we set equal to 0. So move these guys over. I get x squared minus 6x plus 5 equals 0. So we factor x minus 5, x minus 1. And we get x equals 1 and 5. So this is 1 and that is 5. So my limits, my radial equations from left to right, 1 and 5. Right, so anytime you don't have the intersection or the limits, you have to find them yourself by setting the two equations equal to each other. You go from left to right, so 1 and 5. If I'm going to do this by hand, we simplify this, distribute first. So we're going to integrate from 1 to 5 of x minus 12 minus x squared plus 5x plus 7. And then we get 1, 5 of negative x squared plus 6x minus 5 dx. Integrate, add 1 to the power, divide by our new power. So we're going to get negative x cubed over 3 plus 3x squared minus 5x from 1 to 5. And again, same thing. Plug 5 into all of these minus plugging 1 into all of these. So it's going to be negative 5 cubed over 3 plus 3, 5 squared minus 5 times 5 minus subbing 1 for everything. Negative 1 cubed over 3 plus 3 times negative 1 squared minus 5 times negative 1. If we were for response, you could leave it like this, but if we were in multiple choice, we have to simplify it, and we would 32 over 3. Remember, this right here would be a negative 1/3. So that's the answer to that one. So what's the next one? I'll look at this one. We have 3 lines here. Finally, they're bounded by the curves of y equals 2 over x squared, which is this pinkish one right here. Y equals 2x, which is one of these, and y equals x. 2x has a sharper slope, so it'll be the blue one. So this will be y equals 2x, be y equals x, and this is 2 over x squared. So we're looking for this area right here. Now the first thing you should notice on this one, I'm actually set up 2 different integrals. There's a different top function here. It splits right down the middle. Right, so on this left side here, the blue one's on top, the green one's on the bottom. On the right side, the pink one's on top and the green one's on the bottom. So I'm at 2 separate integrals. I'm at blue minus green plus the integral of pink minus green. Now I still gotta find the intersection. Looks like I started at 0. But I gotta figure out where this intersection is. I gotta figure out where blue and pink meet. So do what we always do, set them equal to each other. So I gotta set 2 over x squared equal to 2x to figure out where this guy is. Cross multiply, I get 2x cubed equals 2. So I get x cubed equals 1. So x equals 1. You gotta be sure. I know it looks like it, but you gotta be sure. And I gotta see where this guy hits to find out my last integral right there. So that's where pink and green meet. So I'm gonna set the pink and green equations equal to each other. So that'll be this guy and this guy. So I'll do that right here. 2 over x squared equals x. Cross multiply again. X cubed equals 2. And not as pretty. Cube root of 2 is where they hit. So I get this. Alright, so again, I gotta set up 2 integrals. Why? Because there's a different top. It's all about top minus bottom. So from here to 1, blue's on top, green's on the bottom. On the right hand side, pink's on top and green's on the bottom. So I gotta set up 2 separate integrals for that. So something to this effect. So we get the integral from 0 to 1 of 2x minus x plus dx. The integral from 1 to 3 cube root of 2, and then pink's on top, so 2 over x squared minus green, which is this x dx. Now if I'm solve it, I solve each one separately. So I can simplify this guy a little first. So that's the integral from 0 to 1 of x dx. This one I really can't do anything about. I could write it like this though. Then we just integrate everything, add 1 to the power, divide by minus power. I get x squared over 2 from 0 to 1, plus add 1 to the power, divide by minus power, negative 2x to the negative 1, minus add 1 to the power, divide by minus power, x squared over 2 from 1 to 3 over rad 2. Cube root 3 rad 2. Cube root of 2. There you go. So it's kind of like 3. Then, either way, so again, we're here, it looks disgusting. I don't care if it's without multiple choice or if you're just font, you do have to go further than this. So this one's easy enough. That's just 1/2 minus 0 over 2 if you want to. This side's a little more disgusting. So it's going to be, let me move this to negative 2 over x minus x squared over 2. So it's going to be negative 2 over cube root of 2 minus x squared, so cube root of 2 squared over 2 minus, now we will plug 1 into everything, so negative 2 minus 1/2. So we get that. And again, in this case, now you can leave it, and we are done with that problem. Let's look at a couple multiple choice AP questions. The area of the region bounded by the lines x equals 0, x equals 2, and y equals 0, and the curve y equals x over e to the x over 2 is. So again, now notice I'm going to have to simplify this one pretty down because it's multiple choice. First, let me draw a sketch of what's going on. So we have x equals 0, which is this line. X equals 2, so like that line. This is my x and y axis. Y equals 0, that's just the x-axis. This is the y-axis, by the way. So it's where y equals 0, so this line. And y equals e to x over 2. Now I don't know what e to x over 2 looks like, but I know what e looks like. So it looks into this effect. So essentially we're integrating e to the x over 2 from 0 to 2. It's just bounded by minus 0 if you want to go do that, right? Top minus bottom. Top is this guy, bottom is that line. But I really don't need the minus 0 there. So we just got to simplify this. So let me rewrite it real quick. Right, here's the top function, my bottom function. Integral of that's this reverse chain rule. So copy it. And then 1 over derivative of the power, derivative of that is 1/2. We're going from 0 to 2. So if I'll simplify that a little bit, it'll be 2e to the x over 2 from 0 to 2. Top minus bottom, so 2e to the 2 over 2 minus 2e to the 0 over 2. Don't forget, e to the 0 is 1, not 0. So I get 2e to the first minus 2, also known as 2e minus 1, which would be this guy right there. So that's our answer. 17. What is the area of the region completely bounded by the curve y equals negative x squared plus x minus 6 plus 6 and the line y equals 4. So again, first it helps if you draw a picture of it. So I know the line y equals 4 looks like 1, 2, 3, 4. That's the line. Now this guy, I know it's a parabola, I know it's opening down. But let me find, and I know my y-intercept is 6. So I probably know it's going to probably look like this. But if I actually really want to find out where it looks like, where it hits, I could find the y-intercept, the x-intercept if I want to. Set equal to 0. So I get x squared minus x minus 6. I get x minus 3x plus 2. So x equals 3 and negative 2. I'm not sure if I actually needed that. So it looks kind of like this. I didn't really need that. I just needed this part right there. What I do need, though, is the intersection. So I need to know where that graph and this graph hit. So I'm looking for those guys. So remember how we find the intersection? We set the equations equal to each other. So I'm going to set negative x squared plus x plus 6 equal to 4. And we do what we always do. Set equal to 0. So I'm going to move everything to that side. I don't like having negative x squares. So I'm going to get x squared minus x minus 2. Factor it. X minus 2, x plus 1. So I get x equals negative 1 and 2. So those are my limits. So now we got to integrate that guy from negative 1 to 2. Top minus bottom. My top equation is the parabola. So negative x squared plus x plus 6 minus the bottom equation, which is y equals 4 dx. Simplify a little bit first. I'm going to get negative x squared plus x plus 2 dx. Now we can integrate it into the power divided by my new power. So I get negative x cubed over 3 plus x squared over 2 plus 2x from negative 1 to 2. And again, this is multiple choice. I gotta simplify it. So I know it looks ugly, but we gotta do the algebra of it. So top minus bottom. So the top is gonna be negative 2 cubed over 3 plus 2 squared over 2 plus 2 times 2 minus the bottom, negative 1 cubed over 3 plus negative 1 squared over 2 plus 2 times negative 1. Okay, no going out of this. It's multiple choice. We have to get this answer. So this will be negative 8 over 3 plus 4 over 2, so just 2 plus 4. And then this will be negative 1/3 plus 1/2 minus 2. Substitute the negative, so I get negative 8/3 plus 6. This negative goes to everything. So plus 1/3 minus 1/2 plus 2. I probably want to do a common denominator. So I'm going to put everything over 6. So let's multiply this by 2 over 2. So negative 16 over 6 plus multiply this by 3 over 3. So 18 over 3. Over 6 I said, right? So this is 6. So multiply by 6 over 6. 36 over 6 times by 2 over 2. So plus 2 over 6 times by 3 over 3. So that's going to be minus 3 over 6, and then times by 6 over 6. So 12 over 6. Add up all the tops. I get, what do I get? I get 20 plus 2 minus 3 plus 12. So I get 20 minus 1 plus 12. So I get 19, 20 plus 11. So 31 over 6 is my answer. And that is right there. Thank goodness. But yeah, right again, multiple choice. You have to go through it. So I went through all the math, cut down here. I was like, probably the best way to do it with fractions is just make them all the same fraction. So try to put everything over 6. So I'd multiply this by 2 over 2, 6 over 6, 2 over 2, 3 over 3. Then just add up the like terms. And I get this. Whew. Okay, one more problem. Let's do a free response AP question right now. Let me clear the board. So graphing calculators required for some parts for us. We do get you the calculator for this one. So let's see what's going on. Let R be the region bounded by the graphs of y equals sine pi x and y equals x cubed minus 4x, as shown in the figure above. Find the area of R. Okay, so R is just going to be, right, top minus bottom from 0 to 2. Now, if you're not sure which equation which you put in your calculator, but top looks like it's sine of pi x, and the bottom is this x cubed problem. But if you're not sure, put in your calculator. So let's do that anyway. Let's try to graph it. So I typed it in. Keep in mind, pi is right here, second caret. And I'm going to graph this, but let me change my window first before I hit graph, right? Notice you always want to match the window they give you. So my x is going to go from 0 to 2. And then my y is going to go from negative 3 to 1. You just want to be able to match it so it looks the same. So if I graph this, you see the first graph I had in there, which was the sine graph, is the first one. So yeah, sine is on top and R is on the bottom. So when I do my integral for A, I'm just going to be integral from 0 to 2. So here's a little trick. If you don't want to write the whole thing out, just write like A of x and B of x. As long as we know what you're talking about, you just write A of x minus B of x dx. And on your calculator, you gotta make sure you're always in radians. We're gonna go math 9 for f integral. We're gonna go 0 to 2. And again, I typed them both in, so I have alpha y equals alpha trace y1 minus y2, alpha 4, y2 this time, and then x. And it gives me an answer of 4. Nice and easy. Okay, that's A. Let's talk about B. The horizontal line y equals -2 splits the region R into 2 parts. Write do not evaluate an integral expression for the area of the parts of R that is below the horizontal line. So I want you to draw a horizontal line of y equals 2. So it's right here. Equals -2. So all they want is write but don't evaluate an integral expression for the area of parts of R that are below the horizontal line. So they want this area right there. Now part of this is easy, like that's not hard. So all I'm gonna do for B is integral it's gonna be top minus bottom. I already have and again it's also just right. I don't have to evaluate it. I already have my top equation. That is this guy. That's the top equation. So -2 minus the bottom equation. Well, that was the x cubed graph, was the bottom equation. So parentheses, very important, x cubed minus 4x dx. The thing I do not have are the limits. That's the one thing I do not have. So I got to find that. So there's 2 ways to solve it, right? I could set -2 equal to x cubed, right? I want to find out where these guys cross. Equal to x cubed minus 4x. I missed it for a second. I'll tell you right now, that's a hard thing to solve. I have said equal to 0, but that's not easy to solve. That's why we could use the calculator. So in our calculator, I'm going to plug it in and solve it by hand. I could get rid of this equation now. I don't really need it. I'm just going to put -2 in instead. I didn't have to do that, but I wasn't going to need it. So I'm just going to do this. So there's -2, and there's this thing. Again, I want to find where they cross. So second calculator, intersection. It's got to move closer to the 1 answer. Hit enter a couple of times. And I get my first intersection point is x equals 5.39187. So x equals 0.539187. Again, if you want, you can label that like a or something, lowercase a. Now, if I had to solve this by hand, this one doesn't ask me to, but if I wanted to solve by hand, I could always store this value. So I put second quit. I could store into any variable I want. Again, I don't need to do on this one because they don't actually want me to evaluate it, but I could. Now we got to find the other intersection point. So go back to my graph. Second calculator, intersect. Move closer to the other intersection point. There we go. Hit enter, 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 and I get 1.6751. Remember, if you are going to store if they do, I don't have to solve it, but they do want me to solve it. You do have to store it because you can't just like round it. You get the wrong answer. So if I wanted to solve it, I could store this. So I quit, store, and place into any variable I want. I'm at alpha, so I could do it that way. But in this problem, I didn't have to. Just want me to write the equation. So that is the answer, and that is this lesson.